Hello and welcome. In this video, we're going to be discussing how to solve power equations with positive rational exponents. Before we begin with this problem, let's review a few background concepts. So the first one is how we would simplify x squared to the third power. So remember, the way we handle powers to powers was we multiply those exponents together. So in this case, I would take 2 times 3, which would give me x to the sixth. The second idea is I want to look back at how we solved power equations where I had an even exponent. So if we look at number 2, we've got x squared equals 9. So the way that we undid the square was we took the square root of both sides. And that left us, in this case, with x equals square root of 9 is 3. But if I left my answer at that, I would actually be missing a solution. So can you think of another number squared that would equal 9? Well, yeah, actually 3 works, but also negative 3 works. So what happened? Well, when I take an even root of both sides, like square root or fourth root or sixth root or eighth root, I need to make sure that I have a plus or minus so that I catch all the solutions. So in this case, my answers would not just be 3, it would be positive 3 as well as negative 3. What about when I am solving power equations where I have an odd exponent, like in number 3? Well, to undo that exponent, again, I would apply a radical. In this case, I would apply the cube root of both sides, right, to both sides of the equation. And so I'd be left with x on the left-hand side. On the right-hand side, I'd be left with cube root of 8 is 2. Now the question becomes, did I catch all my solutions? In other words, is negative 2 also a solution? Well, the answer here is I did catch all my solutions. Why? Well, when I take a negative 2 and I raise it to an odd power, like 3, I end up with a negative number. And since that's clearly not equal to 8, the original, in my original equation, I know that negative 2 is not a solution. So the only solution to number 3 is x equals 2. So the bottom line is when I take an even root of both sides, that's when I need this plus or minus thing. When I'm taking the odd root of both sides, or an odd root of both sides, I don't need the plus or minus thing. Okay, so let's see how all those ideas apply to this problem. Okay, so the first thing is I would love to, when I look at this equation, I would love to make this exponent into a 1. So the way that I'm going to do that is I'm going to raise both sides to a power. Because I know that when I raise the left-hand side to a power, the exponents are going to end up being multiplied. So the power I'm going to choose is going to be the reciprocal of this guy. So I'm going to raise this side to the 2/3 power, and I'm going to raise this side to the 2/3 power. Okay, so on the left-hand side, when I multiply these exponents together, 3 over 2 times 2 over 3, 3 times 2 is 6, 2 times 3 is 6, so 6 over 6 is 1. So I'm left with z minus 5 to the power of 1, so mission accomplished there. On the other side, remember that when I have a fractional exponent, that really means I have a radical expression. So notice it's a 3, that means I have a cube root. So really what I've done is I've taken the cube root of both sides. So the question is, do I need the plus or minus thing? Well, because it's an odd root, I don't need the plus or minus thing. So all I have to figure out is what's left underneath my radical. Well, what's going to be left is sort of what's left over from that term. So I've got a 2 as my base, and then I have this numerator exponent. So underneath my radical, I'm going to have 2 squared. So on the left side, I've got z minus 5. On the right side, I've got the cube root of, and 2 squared, unfortunately, isn't going to simplify for me because with cube roots, I need 3 factors in order to pull one out. So since I only have 2 2's, I can't pull anything out of this guy, so I'm just stuck with it. So the only thing that I can do to simplify, or excuse me, to solve my equation is just get z alone, so I'm just going to add 5 to both sides. If I do that, I'm left with z on the left side. On the right side, I've got 5 plus the cube root of 4. And that's it. That's my answer. Okay, here's another one for you to try. So pause the video after you've given it a try on your own, restart the video, and see if you got it. Okay, so for this one again, my goal is I want to make this exponent into a 1. So the way I'm going to do that is I'm going to raise both sides to a power. And the power I'm going to choose is going to be the reciprocal of 2/3. So I'm going to choose 3 over 2. On the other side, I've got negative 3 to the 3 over 2. Okay, well, let's see, first of all, if we need that plus or minus thing. So since my denominator in the exponent is a 2, that's really standing for square root. So when I take the square root of both sides, that's an even root. That means I do need the plus or minus. Okay, on the left-hand side, if I look at how this guy's going to simplify, well, 2 over 3 times 3 over 2, again, those are reciprocals, so I just get t minus 2 to the power of 1. On the right-hand side, I get plus or minus, and now I want to write what I have in radical form. So I get plus or minus the square root of, and then underneath the radical, I'll just have what's left. So it's going to be the square root of negative 3 to the third. So if I multiply that out, I've got plus or minus the square root of negative 3 to the third is negative 27. But now I have a little bit of a problem, because the square root of a negative number is not real. And one of the restrictions when I was solving this equation was that t has to be a real number. Well, since the square root of negative 27 is not real, it's imaginary, I can actually stop at this point. So I know that there's going to be no solution because this guy is not a real number. So my answer is no solution.